In this video, we will talk about polymorphism. Polymorphism allows object to be treated as instance of their parent class, promoting flexibility and adaptability in code. So there are a lot of new terms here. Polymorphism, objects we already know, and instance is the new one. So let's talk about one by one. So here we have two things. These are two things that we know in object-oriented programming, right? We are learning object-oriented programming right now. So class, what is class? Class is nothing but just a blueprint, right? And if we create something in the physical memory that we can use, that is object, right? One example is blueprint of home, and creating an actual home in the physical world which is having address in the physical world, right? When you create home, there is a physical address of that home. In our case, that is going to be physical memory. So now it is good. So this process of creating class to object is, there is some term in between which we called as instance. So if we say what is object, object is nothing but an instance of the class. This is how the sentence works, right? Instance. So if we talk about instance, instance is nothing but object itself, but it is instance of class. We say object is instance of class. Let me write it down. Object is nothing but object is instance of, sorry, I'm writing weirdly. Object is instance of a class. So one class can have multiple instance, right? Like we've already seen for example in the previous lectures, that for car lecture, right? In the car example, we were creating car. Let me pick a different color. We were taking one car class, we were creating multiple objects like a car with a red color with two wheels, car with a green color with four wheels, car with maybe blue color with 10 wheels, right? So what are these? What are this? This is another instance, another instance, another instance. So right now we have three instances. One, two, three. What is the blueprint? Blueprint only exists one. So a class is one, but there are three instances of it. What we call instance also object, right? So you can use this word interchangeably. So objects, so now we can say that there are three instances of the car. It means three objects of the car. Understand? So how the syntax looks like? Not the syntax. A class can have multiple objects and or multiple instances. Understand? If someone asks you to create an instance of the class, then it is nothing but just creating an object of it. Understand? So this is what we call as instance. This is what we call as instance of the class. This is the word. Now a new term comes. This is also a concept of object oriented programming. Previously we talked about encapsulation, like creating public, private, different variables, right? So that we can't access some place, we can access in some other class, we can access in some other functions and something like that. That is encapsulation. That is the concept of object oriented programming. So in this one, what we're talking about, polymorphism. Okay, polymorphism is nothing but, the meaning says many forms. So what do you mean by many forms? It can be a function that has many forms. Okay, a function that has many forms. So let me give you an example. In Python, if you add 1 plus 1, it will give you 2. In Python, if you add a plus b, it will give you a b. So what it is doing in terms of, if the digits are either float, integer, or some other thing, it is, the digit is numerical. These are numerical numbers, right? If the digits are numerical, Python is dealing with as addition. But if the digits are not numerical, digits are what? Characters, alphabets, string, right? In Python, we say this as string. If the both digits are string, these are called as concatenation. You can say concat. That means it just added A and B together. Okay? Because A plus B is not something like number, right? A plus B does not gives you like 32 or something. It is not numerical number. So Python internally deals with that. It sees that when both of the number are of same class, see the first condition is this number and this number should belong to same thing, that is numerical. Now this number or this string, this character and this character should be of same data type. Not same data type, but same kind of type. Both are character. Here you can add 1 plus 1.0 also, right? It will give you answer in float because float is having higher priority. So it will do the addition. You cannot do something like 1 plus a. It will say operand mismatch. This is numerical, this is string. So we cannot add it. So this is an error. Okay, we don't do it. But if it is of the same type, it will do addition on one thing and concatenation on the string part. So as we talk about polymorphism, the meaning is the smallest meaning we can have is many forms. And this is one of the example. This plus symbol is acting in two different forms when it is exposing to different values. When it is exposed to different values. Here we have numerical value, we have a string value. So in this example, this plus icon, this plus symbol is acting differently when exposed to different values. In one scenario, it is acting as addition. In one scenario, it is acting as concatenation. So let's see one example of polymorphism. So what is the internal working? Method in different class with the same name can be called interchangeably. So we will talk about that here in this example. So let's see a simple example. So here what I'm doing, I will give you two examples. Okay. First, let me, yeah. And also before getting into this one, because I've used this function here, method overriding. Method overriding. So suppose I have a class called car and it is not the class I have created. It is the class someone else has created. Okay. Now this car class has a function called wheels. Okay. Suppose it has a function called wheels self and it takes some other argument. Okay. We are not talking about argument here. And it just returns number of wheels. Okay. This function just give you number of wheels. Now you have a class and now suppose you have created your brand X. Okay. You are inheriting this class so that you can use its properties, right? This is why we create classes. This is called inheritance, right? So we have created our new class brand X. We have inherited car, which is this class. Okay. This is the class. We have inherited it. Okay. So now we can use properties of car. But I have created brand X and I don't want this wheels to return me wheel. I want it to return everything. Like I want to return dimension of wheel. I want to return number of wheels. I want to return price of wheels. Suppose this is what I want with this wheel function. If I want to call wheels function, this should return it. So you may be asking why to use this car itself, right? But this is just one of the example. Maybe this car class has all those other properties which I want. Color, doors, engine, and everything, but I just don't like this wheel function, right? So I cannot create all the whole car class, right? Because that is very time consuming. If 9 out of 10 things are present, why should I create a new class for this one function which I want to change, right? So what I will do, I will use method override. Okay, I will use method overriding. Method overriding is nothing but I will write the same function name exactly same, and I can change its parameter. Maybe I want engine, whatever I want to do with function, but the method name should be same, and then I can write the code for it. So what this will do, even though this car already has wheels, we are changing its definition. We are changing its working. Okay, this wheels and this wheels are same. Because we are inheriting it, we can change it as well. So here we are changing it, so the meaning itself is changed, and other things I can use as it is. Because what I'm doing here, I'm writing multiple coding steps here. Suppose here only one line was there, now I'm introducing 10 lines, new lines, not the same. Okay, you can do the same as well. So what I'm doing here, I'm just changing the definition of this function here, and others I will keep as it is. Like I will not define it, I will just use suppose color. Okay, color I will pass as red. I'm just using it here because this color is already suppose this color is already defined in car class. So I'm just using it here, but I don't like wheels of it, so I am defining it. That's why I mentioned def, right? So this is the same name as this car class. So this is called method overriding. Okay, this is also comes under polymorphism. This is called method overriding. So in this example, let's see the example of method overriding as well as polymorphism. Okay, so I've created a class called add, and suppose I have a function add. Now I have another class called calculation where I am doing some calculation. Okay, now this add class has functionality which I want to change. Okay, suppose this is 10 more functions which is useful to me, but only this function is not useful to me. So what I'm doing here, I'm inheriting it because I want to use suppose 10 more examples, 10 more functions of it, but I only want to change add because I don't like it. So this is where I have written add. You can see if I click on double add, it is showing me this add and this add as well. Okay, so what I'm doing here in the class calculation, I'm inheriting add class. So all the properties of add class will come into my class. Now what I'm doing, I'm changing the definition. What is the definition previously? Nothing. Previously when we call add, it does nothing. So what I'm doing here, creating a new add, def add, and changing the arguments, changing the property, how it works. So you can see the first variable should be self. Everything is self inside class. That is correct. I'm creating three more arguments, value 1, value 2, value 3 equals to 0. We will learn about this later when we talk about arguments. And what I'm doing with the value 1 plus value 2 plus value 3, right? I'm just adding it. You may be thinking that how I can return and do calculation in the same line. This is possible. Either you can do this or just store into a new variable. Maybe variable name is temp, and then just return temp. Okay, this is the same thing as, because this is the calculation done by Python and it will store into value. Now if I copy this and paste here, this is same. I'm just commenting it. This is same because Python goes from top to down and right to left, right? It will do the calculation, store into memory, and then return that value. Okay, I'm not printing it because I want to utilize this value right now. Okay, I want to utilize this value from this class. Either I can store it, print it, whatever I want. This is what I'm doing right now. So this is what we have done. A new class is there named class calculation. We are inheriting one class, that is add. We are overriding add because we didn't like the old method. Okay, so we are changing it and we made it like this one. Okay, so now let's create the instance of the class. If you create the instance of the class, what we will get? Object. Okay, instance and objects are interchangeable words. So this is the instance of the class, that is cal1. And what I'm doing in cal1, I'm because cal1 is object of calculation, so it has access to everything. So if I'm calling cal1.add, I'm passing 2 comma 3, because self is memory, so it does not pass into first one, it will pass into value 1, value 2, value 3. Understand? We've already learned about this, right? So I'm passing 2 comma 3, so 2 will come to value 1, 3 will come to value 2, and value 3, this is called by default argument. Okay, so as you can see, I in the first argument I've passing 2 and 3, in the second I'm passing 2, 3, 4, 3 values. When I run it, Python will not give me error. Python will not say that 2 arguments are present, you passing 3, or 3 arguments are present, you are passing 2, because in total we have 3 arguments. We are handling with default argument. So see this Python, right? Same function is acting as different forms. Same function when we are calling with 2 values is able to add. Same function when we are calling with 3 values also is acting as add. Right? It is giving us calculation, it is handling it. So this is example of polymorphism as well. Same function act as many forms. Okay, if you pass 2 value, it will give addition of 2 value. If you pass 3 value, it will give addition of 3 value. Same function is acting as, did I write two functions separately like this? This will take, did I write something like this? Two different function. This can be done with two different function, right? If I write two add function with different values, now this is not polymorphism. I have to create two different variables and the name should be different, right? Add and add one. I can do the same thing with this function, right? See, it is doing the same thing, but now I have to create another function, because if I pass three variables here, Python will say calculation.add. This add function takes three positional argument, but four were given because self is there, right? So we have passed 1, 2, 3 and 4 is self, right? So three arguments were present, but you are passing 4. This is wrong, right? Because add 1 takes 4 positional argument, including self. Self is included, okay? So to fix it, we will do polymorphism. This is the polymorphism. Let me remove it. Maybe it is creating too much of weird codes. So 1, 2, 3. Even if I pass 2, it is able to handle. Even if I pass 3, it is able to handle. We will talk about this later, but this is called polymorphism. One function can have many forms. In this example, add is having many forms, like 2 addition, 3 addition, it is able to handle. This is polymorphism. So let's understand a different example as well. This is also polymorphism. So here we have two classes. Class blood test, which is having function name perform test. Class urine test, which is having the same function as perform test but different meaning. This one is returning blood test results obtained. This one is doing urine test results obtained. Okay, same function name, different functionality, and two different classes. Now there is another function called get test results, which accept some variable and it performs perform test. Okay, now let me give you an example of function. If I want to create function of def add and I write a comma b, I can do c equals to a plus b, then return c or print c. It's up to you. You want to return it, you want to print it, right? So what is a and b here are? A and b are variables. In the first class itself, I have mentioned that variables are nothing but variables hold the address, okay, variable hold the address of the memory location where the value is stored. Okay, variable hold the address of the memory location where value is stored, right? So if the a is having 3 and b is having 2, Python will just do addition. Python does not know that what we are adding here. It first put the value 3, it first puts the value 2, then it will check if it is of numerical type or not, then only it will do addition. Then it is stored into C, right? So a and b are nothing but variable. So if I write, suppose my class is having calculation, I'm creating object and storing into ob1. ob1 is also a variable that has address in the memory location where everything of this class is into memory, that is object, right? So this object is just the address of where this calculation everything is getting stored, okay? Like the functions, memory, variable, subtraction, addition, whatever we are doing inside class is stored in memory. So object is also a variable, right? So in this function, what we are doing, just see this example, okay? Don't focus right now, but just understand this one. We are creating object of blood test, we are creating object of urine test, okay? So there are two classes, we are creating both of them objects separately. Blood test object is named as blood test, urine test object is named as urine test. So this blood test holds address of the memory in of blood test, okay? This blood test variable holds the address where the object of blood test is stored in the memory. I'm saying it again. Blood test is a variable that holds address of the object or the space stored in the memory for blood test class. Urine test holds the address of the memory space occupied by urine test. Okay, so we have two class instance or two objects of different classes. So what are we doing? We are passing blood test into one function. What is this function? Get test results. Because this is a variable, blood test, we are passing blood test and this is test. Let me write it down. Okay, otherwise you could get confused. Let's understand the function. What is a function? Get test results. Variable name is test. And what are we doing? Return test dot perform test. Okay, now we have two object, blood test and urine test. These are object, these are already, these have the address. So what are we doing? We are passing get test results and we are passing blood test variable. Let me write it down with a different color. We are passing blood test object in the argument. Okay, yeah, so we are calling this is a function. This is a function. This function has a parameter called test and we are doing test.perform test. This is confusing now, but we have two variables, 1 and 2. This is an object, this is also an object of different class. So what are we doing? In this function we are passing blood test. Blood test is nothing but variable. So what is mentioned here? Test. So test is assigning a value of, right? It is nothing but if when I write addition of a comma b, and when we pass add 2 comma 3, what happens? 2 assigns to a, 3 assigns to b. Same thing here. When I'm passing blood test is also a value, right? It is a variable. We can assign a variable value. Blood test will be assigned to test. Let me mark it as green. Blood test will go to test. So now test stores address. Suppose this object is there, right? Blood test knows the address. So now when we assign blood test to test, test will also point out to OB. Understand? So now blood test and test knows the address of object. Which object? Object of this class. Okay, it is very simple. So now what are we doing? Test dot perform test. Now test and blood test point to the same object, and we are calling perform test. You can see test is pointing to blood test object now. That is this object. Okay, this is a variable that points to object. Let me draw it more clearly here. So now blood test and test are variable that are pointing to some space in memory, which is, and in this memory we have object of blood test class. Okay, this is blood test class. So now both these variables, from both these variables we can access perform test. We can either write blood test dot perform test, or we can write test dot perform test, because these both are nothing but just the same memory location, just pointing out to the same memory location. So this is what we are doing. See this again. We have created two classes instance. One is blood test and urine test. There is function which accepts one variable. Right now it is empty because it is a function, right? It accepts one variable and it wants to access this. Dot means we are accessing something inside it, right? This variable dot, we are accessing some function here. So it means this variable should be class. So we are passing class object here. Understand? We are passing object here. So get test results, we are passing blood test object, and in this one we are passing, and in this function we are doing this calculation, test or perform test. So what I wanted to show, why I wanted to show this, let me copy this, and this time we will pass urine test object, and let's run it. Understand? So we have passed urine test. So in this one you can see now that the same function is performing in two different ways. This is called polymorphism, many forms, right? But here we are passing the same function because it is just using perform test, and perform test is mentioned in both the classes. Understand? So let's recap it. We have two classes, blood test and urine test. Both classes have the same function name, perform test and perform test, but both are returning different object. So it means blood test perform test is different, urine test perform test is different, but the function name is same. So what are we doing? We are creating object of it. We have created one function that access only the perform test of it. So when we pass blood test and urine test, because both are having perform test function, it will work differently. You can see blood test results obtained, urine test results obtained. So why I am doing it? We only have created one class. Suppose I have, in this example, see, I have mentioned also why we use polymorphism. So polymorphism is crucial in healthcare for handling diverse types of medical tests under a common interface. Okay. Diverse type of medical test under a common interface. What is a common interface? This is the common interface. It always access perform test, but perform test can be different in different tests. Like in this blood test, we are doing this perform test. In this urine test, we perform this test. So in the same name, that is in this common interface, we can have multiple tests. For example, different tests like blood test and urine test, a common method name, perform test, allowing seamless integration into our system. So we are not creating two different interfaces, we are creating only one interface. Now suppose this example is for only two tests. We have thyroid test, we have urine test, we have COVID test, and the same function will be perform test. How to use all of them in a single interface? Like this one. So we will just pass the object and we will do the test similarly. Understand? So why polymorphism is used? Polymorphism means many forms. Polymorphism allows objects to be treated as instance of their parent class. This is what I've done. Add right. Promoting flexibility and adaptability in code. Okay. So this is called polymorphism. And don't worry about polymorphism too much. I know this is a lot to digest. There are a lot of variables we are passing here. We are accessing things and all. We don't usually use polymorphism in normal code. Even if you implement AI, you don't need to worry about it. Okay. We mostly use inheritance. Polymorphism you will see very rarely. Okay. And even if you're using it, you will not know. Just like the example we have talked about, we were talking about this example. Even if you're using it, you will never know that you're using polymorphism. But after learning it, you will at least get an idea, oh, this is how polymorphism looks like, and this is what polymorphism is. Okay, so there are a lot, polymorphism is a big concept. It covers a lot of different things like this example, where we are having a common interface and accessing all the perform test of different classes. Okay, using the same interface. This is the same interface, right? We are just passing the class object and getting different results. This is another example. We are inheriting parent class and changing the property of it. This is also called inheritance. This is also called polymorphism with inheritance. And also this overriding, because of this overriding, because of this variable, because of this argument, we are able to perform two different types of addition with the help of single function. Okay, so we will talk about this after this lecture, that how, what is this variables, what are these arguments and other things. But just understand, same function is able to act differently based on arguments. This is also called polymorphism. This is also a different kind of polymorphism. Understand? So there are multiple types of polymorphism and this covers both of them. So this is it for polymorphism class. See you in the next video.